I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Mike Ewell, President and CEO, A&D Technology. On today's episode, we'll explore how AI and simulation are transforming automotive testing. We hope you enjoy this episode. Mike, welcome to the podcast.
Glad to be here. Thank you.
It's wonderful to have you here. The testing business and simulation business is a growth business as new technologies come online. The number one technology that we have to talk about is AI. Every time you turn on the news, you open a newspaper, I still read newspapers, AI. What impact is AI having on your testing and simulation business?
Well, I think the shortest answer is a positive impact, right? But really, our business has always been AI related. We just have been using different terminology over the years, whether it's automation or road to load to math or road to lab to math, optimization, calibration, look ahead tables, PIDs, APIs, emulators, integration simulator. Essentially, the origins of our business was the original desire to take data from vehicles on the road or on a test track and move that into the lab. And then with time, essentially correlation was the main concern at first, was to make sure it correlated to the road data. But then once correlation was pretty solid and was replicating the road data, then the conversations became, how do we move the lab to math, right? So eliminate labs, eliminate road testing. And that RLM that's been around for decades. So now the M part, which is really the AI part, that's becoming bigger and bigger and more tangible and real every day. And that's the exciting part.
When you started the business, what data were you trying to get out of the vehicles, both on the road and on the track?
Originally, it was just a lot of it was durability and warranty testing, so that you just drive the vehicle all over the place and see how it functioned, see how it degraded, and kind of manually sorting through all that data. So it was more quality in a lot of sense, and you do competitor analysis and that sort of thing, but very, very time consuming and manual.
You have this large data set. How are you mining that data set, finding patterns or trends in that large data set?
So we have LabWorks, which is a data management tool that we have that you can search that data and put limits in and understand what trending there is. Originally that was all manual, so you had a lot of kind of Excel sheet jockeys that would have to manually do that. So it's very, very time consuming.
Now, are you seeing that for your customers? It's the optimizing their products by getting all that data, and they can move quicker than they could have before?
Originally, I think it was about optimization. Now when you automate that, it grows beyond that, right? Now you can really look at what happens when you change things, what happens when if it's a battery, you got different chemistries or a different vendor, and you can do that stuff so much quicker and so much condensed than in the past.
If you're staying on that theme, where does the A&D hardware in the loop simulation platform come in? Where does that fit in when you stay on the electric vehicle trend?
Our hardware platform's open, so you can use. So at the end of the day, when you run a simulation, you need a model. So our hardware platform's kind of agnostic as far as any model can run on it, whether it's Simulink or CarSim or autonomy, whatever system you run on our hardware. You actually can do co-simulation where you're running multiple models on it. So that basically replicates whatever piece the customer doesn't have. So let's pretend a customer is a battery manufacturer, and their battery can go into any vehicle, and the vehicle can have an electric motor from any company, right? So they don't have access, or it's cost prohibitive to have access to, electric motors from all the different vendors all over the world. So you can use the hardware in the loop to simulate what the electric motor would do in real life. So then they have their battery, their real battery, but they're emulating or simulating the electric motor. So that's so hardware in the loop is kind of a generic term for, simulating a piece of hardware. So it can simulate any piece of hardware. It's just a matter of which hardware you want simulated.
And then for the engineers that are using your tool, how do they integrate it into their workflows?
So you got kind of two different things. A lot of times it's kind of inserted into an existing test cell. There was a big change a few years ago where, you had a traditional ICE test cell, let's say, and they wanted to, well, first it started with hybrids. So you got a hybrid element, but, they're not battery manufacturers, but they got to simulate the battery. So you could take a traditional internal combustion engine test cell, you add in the Hill system, and that Hill system simulates a battery, a hybrid battery, right?
So the platform's open architecture. Why open architecture?
So for us, I mean, that's fundamentally our pride point, right? That we're open. A lot of customers or a lot of competitors will, they have a wider range of breadth as far as product offerings. So they like to make it a little more proprietary. So our philosophy is, you got to be open. We be agnostic. Customers, you want them to be able to have the freedom to use any ancillary device, regardless of who the vendor is. So that becomes our battle cry every day, is to have that be open.
Does that become a stickiness element for your business where your customers are staying with you because open architecture is a pride point? They don't have to worry about you one day shifting to a closed architecture?
A lot of times it's actually the opposite, right? Because I think everyone says they're open. So when you're selling to someone, you can easily be duped a little bit, right? Particularly if they have a wider offering. So then, because we don't have the entire package, then sometimes others are chosen. But usually those customers typically go a different route, and then we hear from them a couple of years later about returning.
And then they come back and they integrate onto your platform. Are there any restrictions with your open architecture as it relates to third-party integrations?
No, not at all. That is our core competence, and what we take most pride in is, whatever communication protocol, it doesn't matter whoever the vendor is or the manufacturer is, that doesn't matter. So that's when if it's a new device they're changing protocols all the time, or scripting language, if there's whatever becomes the new language, we want to be able to integrate into that. So
how do your team and your engineers stay ahead of the changes that are coming in the market?
A lot of that is customer intimacy, because our customers are Fortune 50 companies, so they have a lot more exposure to what and they're the ones that know what they want to do. So it's really choosing who you want to be a partner with. Volume. Everybody wants volume and growth and that sort of thing. But I always look at it being more important to who's the best collaborative partner, and working with them, and then you're integrating with them and understanding the direction they want to go, and how can you help them in your little niche, right?
Because if you have the collaboration with your partners, that's unlocking new products. Have you had any major technical breakthroughs that have come through with that collaborative relationships that you have with your customers?
Fundamentally, our foundation is data management and data acquisition and hardware in the loop. So those are our fundamental items. So really what it amounts to is there's kind of no breakthroughs in those items, which is good in the sense, because no matter what technology changes, you still need to acquire data. You still need to simulate some hardware, and you still need to manage that data. So, whether you're going from lithium ion to solid state batteries, or, traditional gasoline or diesel, it doesn't really matter. We certainly coordinate that, and there can be some different automation or test cycles that a customer wants, and those we jump on. But our fundamental platform doesn't change. Just the application changes, or the communication protocol changes for us in our world.
From your customer's perspective, is there anything such as too much data where it can kind of create noise?
I think that's a huge problem that exists and has existed the last few years. Is initially, you go back to the old days where you might go into a lab and And there used to be these wheels with little pins on them or pens on them, and you'd pull the piece of paper off and throw it in a folder. And so we went from that to now they're just terabytes of data, and it becomes that's a big challenge for customers. So you're measuring everything. What do you do with it? It's kind of data overload for sure.
But on the opposite side of that, is the data overload, as you termed it, is that helping with simulation? Since there's a vast data set to build different scenarios, though?
Well, so that even gives you more data. So that makes the problem even worse in many cases, right? Okay, you have all this information. What do you do with it?
Is any of that information being used to increase functional safety?
So the nice part, or one thing certainly with safety, is so it's so cost prohibitive to try to test in real life all the different scenarios of safety, whether it's crashing or, penetrating a battery, if we're talking about EVs in particular, but thermal runaway. There's so many of these scenarios that it's very dangerous to test that. I mean, batteries explode and they cost a lot of money. And so when you can simulate all these different options, an infinite amount of options, it makes things safer. Once you get a good, once the simulation itself or the model, once you get a good model, it saves a ton of money and becomes much more safer.
Walk the audience through, if you don't mind, of how you would simulate a battery fire test. Because there's a lot of headlines that we've all seen out there, but how does that simulate it from those different various scenarios?
Well, the simulation part is how can a fire happen, right? So you're really trying to find all the fail scenarios, right? What would make a fire happen? Is it a short circuit? Is it a penetration? Is it a particular type of crash? So those are all the models you can run to find out what would make a fire, or what would make a thermal runaway event that eventually becomes a fire. And so that's what you're trying to hone in on. And you can run an infinite amount of models, which is much more than you could ever do in real life. So that helps with safety.
Every year around, say, August, September, October, the Southeast goes into hurricane season. And we've seen incidents where these batteries get covered in seawater, salt water, and they have issues. Is that a scenario that could be simulated? Because I remember 2 years ago, I was like, what do we do when these things started popping up? Nobody really had an idea what to do.
Absolutely. So that's there's an infinite amount of scenarios in life. So we're just limited to our imagination of what we put into the model, right? So is seawater conductive? Does that contribute? Could it contribute to a short circuit? And if it was a short circuit, where would it be at? And is that, type of a short circuit that could create a fire? Absolutely. So rain, which direction, and what speed of the wind. I mean, there's the improving the model never ends, right? For the simulations. That's when you have these events. There's just infinite things that can happen, and no amount of, and the modeling is better than real life testing, but it still there's a certain amount that's never captured, right? So you're trying to whittle down to, is when you build a building, there's ASHRAE standards, right? And it's like 99% or 99.5% of scenarios are covered if you put this particular HVAC unit in or something like that. It's similar in an analogy in the sense when you're doing these modeling, right? You're only, covering a certain percentage of the scenarios. And then when a failure happens, you load that in, and then the model covers that. So it takes time to get closer to 100%. And you're never at 100%. And that's a whole different discussion about, kind of philosophical discussions about what's acceptable and what's not. And that's complicated, even more so than any engineering.
I took a philosophy class at Stanford and around ethics, and this went on for a long time. So I have to ask, who's making that philosophical decision? Is it your customers? Is it the board of your customers? Who's making that philosophical decision?
Well, I think that's a current struggle, right? There's some safety rules where they try to cover some of that, but honestly, I think a lot of that is just not talked about publicly, right? It's kind of private because there is, and these are that final 1% that takes, that can prevent something from going, right? This is when if you're going to run over to a dog or a human, maybe that's an easy choice. But what if it's a dog versus a cat? In the model, there's a choice. And those things aren't talked about, but that gets down to the philosophical part of all this, right? And the ethical part, and what are the standards? What's acceptable? What's not acceptable? What do you ignore, right?
There's still a lot of scenarios on the AV side. There's certain AVs that still can't, if you have a duck crossing the road. I know it sounds silly, but then that goes into the philosophical question. Do you run the duck over? Do you stop? Or there's all these different scenarios that go into this. When the models are built, are they built for the most common scenarios and perhaps a few outliers that are, let's say, well documented, and then the other stuff kind of just is, well, we don't really talk about that?
Well, I think, so now we're a few years into it, right? And they're really getting more and more into it. Originally, that's how it started, right? You got whatever data, basically you have these scenarios, driving scenarios. And now there's tons of it with Google Earth and go way back with MapQuest and how that evolved into maps and everything else. So there's a lot of scenarios out there which get you to the 90% level, 95% level. And so we've been working on that for years. And with time, what's an acceptable level? And how do you, well, this gets into collaborations, right? Because now you have everybody kind of fighting to become, emerge and become a leader in these areas. So when they find out these scenarios, it becomes kind of proprietary, right? This is our secret sauce, and we found a scenario that nobody else has, and please, come to us. So another, it's becoming more philosophical than anything, but it's like, okay, how do you force, or do you force some sharing of these things, right? And some people will volunteer and share, but others, there's money involved, right? And you're trying to make your company public, or, you got a IPO coming, or you have stock options. So there's a certain amount of selfishness in this whole thing.
But there's a general unwritten rule in automotive, and on the autonomy side, you don't compete on safety. That's just a general unwritten rule that a lot of people. Do we get to the point where some of these safety scenarios for simulation are open source, perhaps under an MIT license or an open source license?
I think, I think it'd have to be something like that once it got to make it really commercial. Because, everything that's going on now is, okay, you got some robo-taxis and you got some robo pizza deliveries and stuff like that, which are pretty mundane, and they're cool. But if it were, if 696 turned into 100% autonomous, it'd have to be open source, and it'd have to be an agreed rule set and an understood risk, and or you're building completely dedicated lanes, which is. Then the cost of that becomes, is this really worth it? Are we spending our billions and billions of dollars on the most altruistic thing, right? It's very interesting. It's very different than engineering. That's for sure.
Road builders have pretty ginormous lobbying budgets, and so they're all for it.
Yeah, and then you got lobbyists, and you have So there's also, even when you think it's altruistic, there's always, with this kind of money, everyone's got a lobbyist at that level, right? Or plural lobbyists, right?
And behind the lobbyist, there's always a motivation. There's something driving it.
Absolutely.
Getting back to the tech, so simulation has come a long way. It's evolving at a rapid pace. How do you see it evolving over the next decade? And on the backside of that, what impact do you see it having on core engineering?
So I think just every day it becomes more and more model math based, right? So, and so initially, I think when that started, it was, well, first it was just, does this work? And, how does it correlate? And where can we save? But as it's improved over the years, the release of new products, you can you take the mundane things instead of recreating code or looking through certain things. You can fast forward right through that, and so you can condense development periods, right? And you can actually change products more frequently or add additions more frequently. I think historically you had if you had to go through a change, just the capital equipment and manpower to do that, it's so restrictive. So you basically delayed change, and in an organization, you'd have so much inertia against change. So it's kind of a set it and forget it mindset where, all right, let's make it this way and let's never change. And now we've kind of gone the opposite way, and everybody, there's all sorts of, how do we be disruptors? And I think there's a lot of disruption for the sake of disruption. So where is the happy median? And there's a lot of, like, you make things redundant just so consumers spend what's the new release each year. So you have these planned obsolescences. And so it's all fluctuating. We'll have to figure it out. The good news is we can do it quicker. We can condense development, but do we really need new things every year? Which is, an interesting topic.
Consumerism's a big part of the U.S. economy. So that opens up a whole
for sure.
Economic thing. Planned obsolescence. We see it on our iPhones. At some point, the battery dies, and there's federal lawsuits and court documents that we could point to back that up. But I'm curious, when do we get to the point where everything that can be simulated will be simulated?
Well, I think you'll get to a high percentage level, right? I think that'll be in the next 10 years, where there's not a whole lot of road testing. There's not a whole lot of test cells, right? It's the goal will be how do you simulate everything? Because then you save money on capital equipment, you save money on engineers. I think then that will happen, but you'll always have a certain percentage of real life testing because you'll never get to 100%. A model being 100% accurate, right? It's just an impossibility. So you can reduce it 99% or 97, whatever percentage. But yeah, there'll be less test cells, less cars driving around Metro Detroit with the camouflage covering, right? That's coming from Milford, right?
Yeah, coming from the proving grounds. Then is simulation the great disruptor in the automotive industry? Perhaps?
Well, I wouldn't be the automotive industry in general. I think it's certainly in a subcategory of testing, right? It's certainly a disruptor.
See, you have the disruptor simulation, you have AI, and then you have digital tools. Building and engineering an electric vehicle is massively complex. What tools are being used today to engineer those vehicles, and how do you see that changing in the future?
So, traditionally, you'd have a test cell and you got a proving grounds, and you're designing it, and like I mentioned, went from the proving grounds to the test cell to simulation, and that'll keep increasing, and you will have shorter development times because of all the models that have gotten better and better and better, and they'll be safer products. There'll be an ability to release products quicker. And I think, from an engineering side of things, I think you'll still need engineers. They'll change a little bit, right? There'll be more of a kind of an integration engineer or systems engineer. I think that'll become, or it already has become, much more important than these individual disciplines, right? Of mechanical or electrical or metallurgical. The system viewpoint becomes much more important from an integration of it all.
We have shorter development times. This is theoretical because I know you're not an automotive OEM, but I'm curious, do we get new models potentially faster out of these 7-year cycles to potentially get new models quicker?
Well, you have so you can't simulate manufacturing yet, right? Well, maybe in the next 10 years you can plug a port into your brain and it 3D prints the car that you didn't even realize you wanted, right? But until that happens, there's manufacturing limitations, and So changing the tool sets out at manufacturing, so that's just still a huge deal. And I don't think, you can simulate and come up with all sorts of different designs, but the tooling is such a huge deal. And just the logistics and raw materials and the supply chain of it, I think the ability, I don't know how much, that could certainly be condensed more, because you don't have any of the delays from engineers. So the engineering portion is reduced now. How much of the 7 years is because of engineering, versus other issues? But certainly, I think it could be condensed. How much? I'm not entirely sure.
It's one of those things we grab a bucket of popcorn and watch and see.
Right. I mean, that's the great part is, we're witnessing this kind of drastic change, which is always fun to be part of, right?
Technology is changing. You're A&D. You're running it. You're at the cusp of new breakthroughs in technology. You're embracing those technologies. How are you staying ahead and leveraging these new tools for the advancements in electrification, automation?
So I mentioned before, customer intimacy is critical, right? And so really, the advancements are, for us, it's usually a protocol change, a new, regulation where there's a particular test cycle that's desired to be run. So we've got to be intimate with our customers. Then we got to implement those changes, whether it's automotive Ethernet so through the years, you had, RS-232 to EtherCAT to Ethernet to automotive Ethernet. So there's always these disruptive changes, right? Or, that could be labeled as disruptive changes. And luckily for my company, it's kind of limited to test cycles and communication protocols and those sorts of things. So it's a lot more manageable. But it goes back to customer intimacy and knowing what direction they're going and what they want to see. And customers have the money and they can easily dictate what we work on.
But they're keeping you well informed, so you're not making investments that don't pan out, because you're taking this collaborative approach. You're learning from your customers and you're building with your customers. Mike, in your opinion, what is the future of the testing and measurement industry?
Well, the future is certainly simulation becomes less of a novelty and more of a fundamental component of it, right? And like we touched on earlier, I think a regulatory piece is missing. So, testing and automation, that's never going to go away. It's just a matter of what shape and form it's in and what regulatory body kind of sets some parameters. So we're in the kind of wild, wild west a little bit right now. So everyone's trying to, differentiate themselves or come up with something nobody else has type of scenario. So I think with time, that'll become more standard. And then you need a rule set and kind of stable out until the next disruptive period, right? Because disruption, what do they say about the only thing that you can count on is change, right? Basically. So, yeah.
That is true. So do we get to a point in the future where for testing and simulation, there is a standard or a regulatory body or regulation that everybody has to abide by?
I think there'll be some things that are required to be tested or confirmed that have been done, from a 30,000 foot level. I think it'll be, digital twins and kind of digital or virtual testing in general. I think it'll funnel into that being a majority of what testing is, period. But how that's done and what you prove or what you certify, I think that'll come out at some point. Particularly if it's completely digital, right? Because it's not real or it's not tangible. So there's how do you certify or the digital model itself or what's included? I envision that happening at some point. If I was smart enough to know where this was completely going, I wouldn't have to work at A&D, right?
Well, I think you're onto something. And when you go full digital, you have an audit log, and you can learn a lot from those digital audit logs and how things are going. We do know that there's a lot of change. It's positive change that's coming in this industry because technology is enabling the testing and measurement industry to give great impact for the customers, such as what you have at A&D Technology. Mike, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I just be open to AI and automation, because it's not going away. So at A&D, I'm proud to be part of this with all the engineering companies and OEMs, and be part of the revolution, and look forward to all these big questions, whether philosophical or engineering wise, to look forward and be part of it. It's a fun time to be in Detroit, a fun time to be part of the automotive landscape change.
The automotive landscape is changing. Mike said it brilliantly. Be open to AI and automation. I'll say embrace AI and automation and build with it. Tomorrow is today. Today is tomorrow. The future is A&D Technology. Mike, thank you so much for coming on SAE Tomorrow Today.
Thank you very much. Been great.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we discuss how Dynisma's virtual testing simulator is accelerating the development of supercars.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.